Hi, Kristen. Thanks so much for joining me today.
Oh, thanks, Dave, for inviting me. It's been a long time since you've been a student in my classroom.
It's true. I think we were actually the first class.
Were you my first year at Bromfield?
Yeah, I mean,
Okay.
I can, if you're okay with me guessing at the year, I will. I think it was 2004.
It would have been the fall of 2004.
So never would I have guessed that I would be in a chemistry related field, but
But there you are, prepared and off you're running.
absolutely. I mean, I get a lot out of this interview series because I'm able to learn about what's going on
hmm hmm
as someone who's not a chemist myself and didn't have even the AP chemistry experience in high
Well,
school.
yeah, we didn't start AP Chem until after you graduated.
Oh,
If
okay.
you were a junior, my first year at Bromfield, we didn't start AP Chem till my third year. You would have graduated already. So
It seems like the AP classes were still just coming along, but part of it's because of the size of the school, I'm sure.
that's part of it too, and student interest. There's been more interest in AP classes in the 20 years that I've been here. So that's definitely made a difference. When the students want to take the class, we're going to try to find a way to offer that when we can.
That's great to hear. So, yeah, today I was hoping we could talk about separation science in general at the high school level,
Sure.
especially for AP chemistry.
hmm
What
hmm
separation methods or experiments do the students encounter, and how does the curriculum prepare them for the future studies in chemistry?
So in AP Chem, there's a big emphasis on gravimetric analysis. Students need to know how to do the analysis of that. And they need to know how it works. If they're making a precipitate, right, they need to be able to filter out the precipitate from the filtrate, collect that, dry it, get the mass of it, et cetera. So that's something that the College Board actually encourages all AP classes to do at least once, preferably more than once, so that the students really know how to do that. Actually, in my first year classes, we'll also do a gravimetric analysis lab where they have to collect a precipitate and filter it out. So we do a lot of filtration. That's a big separation method for me. And in AP chemistry, chromatography is part of the curriculum, not in any great depth, but they do need to know, the solvent front. This is the stationary phase. They're more attracted to one than the other. That's what really controls how far that particular substance travels, relating it to intermolecular forces not on a very sophisticated level, enough to be able to say, oh, gee, I know the solvent is nonpolar and it moved along a long way, had a high RF value. That kind of analysis is something that can show up on the AP exam, and the students remember it best if they've done it. So I always like to do a chromatography lab with my AP students in person if I can. So we will often do paper chromatography, and some years when I have smaller classes, I might do a little bit of thin layer chromatography because I have a sample of all the FD&C approved food dyes. So we can do like, okay, well, here's your mixture. Can you identify the unknown? Or here's the mixture. What solvent will get you optimal separation? So they have to measure RF values and calculate the ratios and all those kinds of things. It's something they are definitely expected to be able to do.
At the American Society of Mass Spec conference, I went to a presentation by a trainer from Axion Labs, and he did a separation just with a column and Kool-Aid that he had
Oh, yes.
pre-mixed.
That's another. I have done that lab too. I have the little set pack cartridges. They're like this tall. They're really tiny little things, and then you can pass the Kool-Aid through it and figure that out. And that actually works really well. You can reuse the columns, but I found in terms of what the College Board wants and the kinds of questions that appear on the AP exam, simple paper chromatography or simple TLC chromatography actually better correlates to the kinds of questions they might need to see. It was hard for students to, I had no problem with it because I did chromatography for years before I started teaching, but like doing the eluent and collecting it in small enough things so they could actually figure out where the one piece, where the one component came through the column. So it's a great lab, it's a classic, but I tend to do more of the paper chromatography with my students.
That makes a lot of sense. As the instructor, how do you help students understand the real world relevance? And certainly for me, someone who lives at a lot of hours of the day, like PFAS is like a big giant topic. At what level is something like water quality or the need for these separations? How
Mm.
exposed are students to those topics?
The tie-in for us is primarily relating it to IMFs. Oh, these guys have similar intermolecular forces, the strength of the attractions are similar, and therefore it doesn't travel very far, or it's really attracted to the mobile phase. And so we do see a lot of distance, you'll see a bigger RF value, and using it in terms of identifying unknowns. And that really tends to be the focus, but that doesn't mean it can't come up in other contexts. It certainly can. My introduction for the TLC lab, where they're identifying which food dye was used in the experiment, the whole introduction to the lab, which came from Flynn Scientific, talks about, you know, the whole the beginnings of why we needed to consider what food dyes are safe and which ones are not, and how do we detect them and things like that. So it'll often sort of get embedded into the introduction to the experiment or as part of a side conversation.
You may have touched on it in terms of what you're actually doing now, but do you have a favorite classroom activity that helps talk about separation techniques?
I do. There are two chromatography labs that I really love, and some of them are virtual. There are some really great virtual experiments to sort of just get the idea across, especially if you're rushed for time and you want to do the experiment itself after the AP exam. But I love the experiment where I give the students, they pick 2 out of the 7 dyes from that are approved, and they actually make their own ratio, and they test them all on paper chromatography under 2 sets of conditions, one in a ethanol water solvent and one in a just plain water solvent or something, 2 different sets, and they try them out and see how they run. That's a very cookbook kind of experiment. Do this, do this, do this, and they learn how to spot the samples and prepare them, and how do you set up your chambers for the chromatography, et cetera. And then the second day of that experiment is, okay, these are the 2 dyes that you had studied. If they're in the same sample and you want to separate them with paper chromatography, what solvent do you think is going to get you the best experiment? Which solvent is going to get you the best ratio, not just the biggest distance between them? What's going to give you the biggest ratio of the RF values, right? And let them pick whatever solvents they can come up with. You want to have ethanol and sodium chloride? Go for it. Here are all these things. Pick out 5 or 6 of them. You need to have a control that's from one of your experiments from yesterday. Which one do you think is going to get the best separation? Go try it out. And then I have them make a little mini poster, not just write up a lab report, but like just putting together a little trifold board, a miniature trifold board, and then they can share their results with the rest of the class. So that's actually a lot of fun to do. They learn the technique and then we do it.
That's very cool.
We just play, like sometimes I'll have my first year students and they am like, hey, you guys have all done paper chromatography, and they give me blank looks. No, I've never done paper chromatography. I'm like, okay, let's get out the markers. Let's get out the chromatography paper. Let's, dip it in some water and watch them move. Look, when you do it with the black markers, there's 4 different colors in there. That can be a lot of fun. And there are a lot of variants on that you can do with like circular. You can take like filter paper and fold it into a cone and make designs and have it sort of be radial. So it's very artistic, and they love that. Just being able to have it be pretty at the end, and we can hang it up. So that can be a lot of fun too.
It's probably the most fun to talk about the hands on experiments.
Oh, absolutely. But the virtual experiments, I forget where the simulation is that I found. I sometimes will do it as part of my summer work, just exploring it. You need to see how they work, and you can make comparisons. You can try it out multiple times. It gives you immediate feedback. That can be really helpful when you're trying to figure out kind of what this is working, how this works when it's your first time ever learning about this method at all.
Is it challenging to balance the discussion of those theoretical aspects and balancing that with like the experimentation time?
We have very limited class time compared to when you were at Bromfield. We have a new schedule, and so our classes
Mm-hmm.
are longer, but we only have 5 each day. So the students are still taking 7 courses, but only 5 of them meet on any given day. So instead of every class meeting every day, you're meeting 5 out of 7 periods. And so you have to really think carefully about how long will this activity take. I can't spend 3 days on a lab before the AP exam and still get all the required content and skills done. So I have to be very thoughtful about that. Is this a lab I can do in one period? Is it a lab where I need to come back the next day to get the final mass? We do a lot of filtration. They're very good at filtration.
Yeah, I figured that would be the largest challenge in terms of everything being so time intensive, also
Right.
the limits on equipment you might deal with. But what other
Um,
challenges are there?
though, really, I mean, I do the labs that I want to do. If there's ever been a new lab that I wanted to try, we've been able to get the equipment for that. We're not going to do any distillation in the high school level. That's not something I'm interested in. I actually have one set of distillation apparatus, and I mention it to the kids, but it's not really something I need to worry about with this level of chemistry. That's really college organic lab time, and it can wait till then. I'm just fine with that. I'm trying to think about other separation methods that we do. I mean, we do a little decanting, but it's pretty low key because honestly, these are all new skills for high school students, and they have to learn how to manipulate all the glassware. Just that alone is enough to keep them pretty busy.
Absolutely. What misconceptions do students have about separation science when they're first learning about some of these topics?
I don't think they always realize like it can take a lot of time, and also that we only might do it once or twice, when they're in class with me. To get good at doing separations, you need to do them a lot, right? Like if you're going to, how do you load your column? Figuring out all those parameters, it takes a long time to optimize this. They have no idea about any of that, right? They don't realize when we're doing the paper chromatography or the TLC how important it is to spot your sample. You want it to be a small spot, but you need to get a lot in there. But if it's too spread out, you're going to have these big distortions. And they just think this is normal. But I'm like, they have no idea just because they haven't done a lot of separations, right? They've not done any chromatography, paper or column chromatography. And I'm like, I could teach a whole year course just on separation methods. And they just don't know about most of it. They don't realize there's all these other things we could be doing. And that's okay.
Do you have any memorable stories about student engagement or maybe some aha moments that students have
Um,
had over the years?
Oh, they love it when they see the spots coming up. You can see them traveling with the solvent front. That's always fun to watch, but it's also really slow. Sometimes it's like watching paint dry. There's always the moments of, oh, you dropped your sample when you went to put it in your chromatography chamber. It ended up in the solvent instead of being above the solvent, so you have to start over. Or it went too long and it went over the edge of the paper. So those kinds of things are always interesting. Or just how quickly it fades. Like the food coloring ones will fade. Or we tried to do a fruit juice. Like what are the components in fruit juice? And we had a whole chromatography thing. You had to spray it, to visualize it, and it faded in like 3 seconds. Like, oh, yeah, this did not work. We didn't get good data from that lab. It was a lot of fun, but it was hard to get useful data. And I think that's one of the things the students don't always realize. Generally, we're trying to pick labs that are going to work, that they're going to get usable results from them. And of course, it doesn't always work that way. And you may have to try it again, or you have to optimize your sample or optimize your, the solvents, et cetera.
Yeah, it's such an interesting comparison when I'm looking at poster presentations at ACS meeting. 2 or 3 years of work
Right.
that a chemist is sharing, and then luckily through this interview series, I'm able to put that online and discuss it and hopefully share it with more people. But there's obviously, on the other end of the spectrum, your limits with class time and scheduling.
And there's all this other content they need to learn. They don't know any of the other lab skills either. At some point, we have to make sure they can read a graduated cylinder. Can you just use the balance without spilling things all over the table? And so we don't spend as much time on separations as I'd like. On the other hand, we do what they need to have so that when they take those courses in college, they've filtered something before, besides coffee. Um, when it's time to use a SEP funnel, they understand that, okay, it's going to be more likely to dissolve in the solvent A than in solvent B, and I can separate them based on that. We kind of prepare them for it. At least that's the goal. I don't know, my favorite chromatography method. When I was a protein chemist, I had pumps and I had automated systems. That was kind of cool to optimize. How do I isolate this protein from the bacteria I just killed in huge quantities and collect the protein? That was a lot of fun. It was intellectually very satisfying to figure that out and to think about all the different chromatography methods I got to explore, doing size exclusion, doing all the affinity chromatography. Like there's so many chromatography applications or strategies that I don't have time to talk about with my students.
Yeah, that's a very interesting topic in terms of chemists who leave the bench.
Mm-hmm.
Certainly staying in academia in one facet or another, you're still there in that sense. But on the industry side, which is kind of in my world, you have a lot of people who became bench chemists full time after many years of school and
Mm-hmm.
found out they just really didn't like that
Right.
life, and then
Right.
for whatever reason ended up more, whether it was doing sales, or I certainly know and come across a lot of very happy application scientists
Mm-hmm.
who work for
Mm-hmm.
companies larger than Organimation who
Right.
do that bench work in industry.
Right.
One challenge a trade group that we've always been in close contact with, the Laboratory Products Association, is really sharing more at the undergraduate level
Mm-hmm.
that, hey, there are these careers outside of academia for you to
Right.
consider.
And that was something that didn't come up a lot. I mean, I knew about, I had a lot of respect for my college professors and, I'm still in contact with some of my grad school professors, but we didn't really talk about there was industry, like you just sort of like you work in an industry lab or you become a postdoc and you have an academic career. And they didn't talk about some of the other ways you might do that. So,
And certainly it's a really great place, in my opinion, for doing useful sales work, and that
mhm,
people either have a defined need for the product or they
right,
don't, and you can more take that helpful advisor role, and
right.
it's the furthest thing from like used car sales.
Right. Well, I know that there are companies that have staff members whose job it is to basically run preliminary experiments for you as proof of concept. This will actually work. We can actually take your samples and get the data out from it from all these different separation methods, and therefore you should buy our instrument.
A few years ago, a colleague of mine and I visited a QC lab for Agilent in the
Mhm.
United Kingdom outside of Manchester, and they use our equipment. We were just doing a tour that they were nice enough to provide, but because that equipment's so expensive, they're getting in the samples for commercial laboratories
Right,
and
right.
kind of showing what they can do.
Exactly.
Um,
Yeah.
and there's certainly a willingness, let's say, to invest the time when you're selling $1 million piece of equipment to demonstrate that
Right.
it works.
I want to make sure it's going to be able to get me data that's usable for me to help me get my grant, to get that paper, to figure out this really interesting, observation and explain it. I don't want to spend $1 million until I know it's going to do what I need it to do. Yep.
That's where Organimation came into play,
Mm-hmm.
was that they were previously, Agilent had been asking for the samples to be prepared and ready to run on the LCMS,
Mm-hmm.
but then they realized, well, we can be more helpful and get in more samples, but we probably need some sample prep equipment,
Right.
and the
Right.
concentrator was what they needed from us.
Mm. Ooh. Yeah, that's the other thing that like high school students aren't really aware of. Oh, we can actually couple these separation methods together and get even more information, right? Like they don't know that GC mass spec exists. They don't know that LC mass, like they don't even know about those combinations. I'm just happy that they know what chromatography is, let alone all these variations and all the iterations and different detectors. And, we don't go into the theory. We just sort of do some simple Like here's the basics of how it works. Here's what you need to measure.
I was thrilled to sit down and talk to you for obvious reasons. I also think that you're just at a very interesting point in the process, which is kind of day one, I would say, in terms of introducing these topics.
It really is. The very first unit that I do with my classes is about atoms and elements and pure substances and mixtures, et cetera. And we talk briefly about separation methods, right? But it's just like chromatography. We're going to separate things based on solubility. Oh, we can do, if we want to talk about, we can just evaporate things. We can do distillation, like, but we just define it. Here's a picture of a distillation apparatus. We're going to separate things on boiling point, and we leave it at that. And so, really, chromatography and filtration are the only ones we end up exploring in any more depth. But they do know that, okay, it's a mixture, we can separate it. That's kind of an important thing to know.
Absolutely. And also topics you have to master. That's really the goal, right? Especially with you're preparing them for the next step of the process, whether it's the AP test, but then also that career track.
Right. Well, a lot of majors require you to take 4 semesters of college chemistry, right? So 2 semesters of freshman chemistry and often 2 semesters of organic. A lot of programs and degrees require that. I want to make sure when they leave Bromfield that they are ready for that. We need to make sure that they've got the skills to be ready to learn about those more advanced applications.
Totally. That was one thing that was a eye opening to me recently at the regional ACS meetings was that typically at a national event when I go to the poster sessions in the evening, I only really have to pay attention to organic and environmental
Mm-hmm.
and analytical. Like those are the posters that are relevant to me. But at the regional meetings where they have the different tracks going, like there's certainly important mass spec topics discussed in
Mm-hmm.
inorganic. So I was hopping from room to room to make sure
Right,
that I could
right,
learn as much as I could. Separation sciences in all facets of chemistry is my
right.
point.
That's what we do talk about mass spec and AP Chem too. General, more about the mass spectrum. I do have a POGIL activity that talks about how the very simplest type of mass specs can be set up. We don't go into any detail. My husband is a mass spec expert. That's what he does. And he'll talk about all these different variations on mass spec because that's what he's done for 30 years in different contexts. I'm like, yeah, we just look at the mass spectrum. There's so much more.
Yeah, that comes back to that introduction component.
Right.
And for me, again, it's important to get outside of the bubble and talk to people, but to me, it's always LCMS, GCMS is like,
Hmm. Well, you can
well,
do
I guess
so
those
much
are
with
two
that. Yeah.
topics, but
Yeah.
yeah, there's obviously still the chromatography and mass spec separation.
Right.
But, well, Dr. V, I really enjoyed the time today. If you ever want to come back on and talk about anything
Anytime
else, you
you
let
want to
me
talk
know.
chemistry with me, Dave, I'll be happy to come talk.
Awesome. Thanks so much.